Okay, so we have here task 3, adding a detention pond. So as I said, the authorities, water companies, councils, or environment agencies in the UK, they expect any developers, they reduce the peak flow after development to the situation before development or pre-development. For one purpose or one task to do that is to add a detention pond. It could be like a one detention pond, or it could be like a distributed a few detention ponds throughout the like a catchments or sub-catchments area. So in this example, we have only one detention pond added at the most downstream points before like discharging to the like the streams or rivers. So we can just locate these ones in here. So we have some specific like the detention pond. So we this kind of like specifications. You can see here there's a few outlets here. So for like the outlet number 1 is for the water quality. Number 2 can capture for like a flood of the 2 years return period. Outlet 3, all of them are defined like as orifice, like the number 1, number 2, and number 3 are designed as an orifice, like the opening, for example. Number 3 is designed for a flood with a 10-year return period. And number 4 is like a weir. It's not orifice. It's like the overflowing from the top. It's like a weir that, this is like the plan, and this is the cross-section view. And that's the weir is designed, the weir is here. The weir is here, but all the other like the outlets, like the orifices, are located somewhere in here, so you can see. But as you can see here, for example, in the design, you can see for the detention pond, the storage for the water quality, the bottom is like very small. For the 2 years, is also like a very small. It has like some slope, the storage. But for the 10 years, we needed to just have like a larger like a capacity, and 100 years it appeared the same as well. So this has already been designed and set by this example. But what we want to do, we have some specific tasks to do to just try to just minimize this one more than this and make it more efficient. Okay, so that's like a one task we need to do. But this has already been designed, as I said. So let's see what is been done already in the example. So you can see here, there is, if you look at the like example number 3, SI, we just convert to the SI units, has already been set. This kind of like the storage unit. The storage unit has got a like this icon at the top here, but has already been set here. But just bear in mind, a storage unit, if it's going to be connected to any joint, okay, or any junction, it has to be through the either orifice or the weir. The orifice and weir are already like some elements at the bottom at here at this kind of like a shortcut. You need to just look at here, but it has already been set. The orifice and is from the type of the conduit, but you need to just set it as the orifice. If you double click on any of them, you can see here all the specifications that we're just going to set it here. For example, for the orifice, this is the orifice number 2. Orifice number 1 is the water quality. Orifice number 2 is the number 2, and is number 3 here. So we have like a 3 orifice, and a specification of the link. Can you see here? Orifice on the left hand side can be defined here, or we have one weir here as well. One weir, or you can see a specification on the left hand page. You can define it as a weir. And there are some specific properties that you need to define. For example, this is transfer type. So you have all of them. And the only way that you can connect the storage, and we have one storage unit here. Can you see the storage unit, SU1? And all the specifications are here, for example. And just pay attention, the way that we design it here. So this kind of like a cross section in the software, there is some specific like the curve that you can define. For example, the curve number. The curve number, you can just define the curve number 1, SU1. But where can we define the curves? In here. So the curves here. There is a storage curve. There is a storage curve that we can create it here, and that storage curve define exactly the one that we shown in here. So this kind of like the curve of the storage and the depth, you can define it here. So if you look at here, that's for level 0 or the depth 0. This is like the area, and for other levels we have defined this one. So anyway, so this has already been said, but just for your information, how you can define this one is this way. So it's connected with the like the orifice or the weir, and here. So we can set it up to like 100 year, and we run the model. So we can see everything is perfectly well. There is no flood here. Everything is perfectly well. So no flooding here. If there's any flooding in the sewer, I mean, in the pipe and nodes upstream, you need to just make sure you can just remove that fan and make sure all the runoff goes through the piping system and discharge in this point. So we're just gonna plot here, very simple. And for the total inflow, forget about the depth, and we're just gonna see the tabular. And for the graph one, plot one, we're just gonna have the same. For the total inflow, accepted, and you can see here. Remember from the previous example, task 2, for 100 years we had above 5,000, but in this example, the designer set it to just become under 900, for the same 100-year return period. So you can see the exact value here. For example, it is 850. 889. Okay, so if you go back to the previous development, it was example 1. If before development, if you're just gonna set for 100-year return period, this is before development. This is, we want to see if the water consultancy did the consultancy do the job properly or not. Okay, we run the model and the outlet before development, if you remember this example, and we plot this one, and we're just gonna go for the total inflow. And you can see exactly this one. So the consultant could get exactly reduce the peak of the flow from the 5,000 to under 900. So this is something that has been done. So please have a look at the task 3 and see what sort of a modification we are going to do to just exactly get to minimize the value to just do that one. So, and we will discuss about this and how we can just improve that one in the class, and we can practice more.